All right, so go ahead for number 1. This is your warm-up, so I want you to pause the video and attempt to solve the problem. So this should be Algebra 2 review. So go ahead and pause the video. When you finish it, go ahead and unpause the video to check to see if you did it correct. All right, so if we look at the situation, it says JJ needs $44,000. He deposits $10,000 into an account paying 3.25 annual interest rate compounded monthly. Solve the equation to determine how long it will take to have a total of $44,000 given the situation. So if we write our A, P, R, N, and T off to the side, we know that our ending amount needs to be $44,000. And we know that initially the amount of money that JJ deposited was $10,000. So that's our principal interest, so our starting amount. And then 1 plus, we have our compound interest formula, so compounded on an account paying 3.25 annual interest. So annual interest, so to figure out our rate, we take our percent, divide it by 100 to find our rate, and we get 0.0325. So our rate is 0.0325. And it says compounded monthly. So how often does monthly happen? Monthly happens 12 times in 1 year, so it goes in both locations. And we don't know our t, that's what we're solving for. So our unknown is in our exponent, meaning that we are going to end up having to use a log to solve. So our first step is to divide by that 10,000, and we should get 4.4 equals 1 plus 0.0325 over 12 to the power of 12t. Now, you can either turn the 1 plus 0.0325 over 12 into a decimal, or you can just use that exact. So we know that the inverse of an exponential is a log, and the base of this exponential is 1 plus 0.0325. So our inverse is going to be log base 1 plus 0.0325 over 12. So we're going to do that to both sides. Log of 1 plus 0.0325 over 12 of 4.4 equals log of 1 plus 0.0325 over 12 of 1 plus 0.0325 over 12 to the power of 12t. This here simplifies to be 1, so we end up getting our log of 1 plus 0.0325 over 12 of 4.4. So that'll go here, and it's equal to 12t. Our last step now to get t by itself is to divide by 12. So we have t equals log base 1 plus 0.0325 over 12 of 4.4, all divided by 12. And when you type that in your calculator, you should get 45.6495. So it'll take a little less than 46 years for JJ to get $44,000. All right, now let's look at our next question. So go ahead, pause the video, take a second to read it. All right, so this says that L of x gives the life expectancy in years for x decades after 1990. So x is the number of decades since 1900. Based on the model, when is the first time? So when is the first time? So we're solving for x. that the human life expectancy is predicted to be 80 years. So we know that our human life expectancy is going to be 80. So we know that L of x is 80 because L of x tells us our life expectancy. Our x is decades after 1900. So we know here we have an equation for L of x, and we want to know when our y is 80. So we can set our equation equal to 80. So now in your calculator, in your y1, you're going to type your first equation, 42.53 plus 13.86 natural log of x. In y2, you're going to type 80. You're then, so this is step 1, going to do second, trace, intersect, to find their intersection point. So we should get that when you find your intersection, you should get that x is 14.931353. But how is x being measured? It's being measured in decades. So if we want to figure out how long after 1900 we had a life expectancy of 80 years, we're going to take our 1900 plus that amount we found. But since it's scaled by decades, we need to multiply that by 10. So we end up getting 1900 plus 149.31353, which we end up getting 2049.313. In our class, we round up 4 decimal places. So now let's look. This would not be the late 1914s. This would not be early 2000. This would be our, well, it's rounding up, early 2050s. All right, good job. So now go ahead, pause the video, and attempt to do example number 1. All right, once you've attempted, let's go ahead through it. In DeKalb County, Illinois, the population of deer in 2010 was 1,500. The population of deer grew at a rate of 3.2% per year since 2010. So let's say this. We know that we have a population in comparison to time. The initial population in 2010 was 1,500. We know that it's going to be increasing, so 1 plus our rate, which is 3.2 divided by 100, to the power of some unknown time. So we're not really sure. So currently, in this situation, so if we simplify this, we get P of t is 1,500 times 1.032 to the power of t, where our current input is years since 2010, and our current output is deer population in DeKalb County. So now let's look at our next question. It says, which of the following functions gives the output values in years since 2010 for input values of the population of deer in DeKalb County? So now basically what we're doing is we have to adjust our equation where we have our t by itself, since our new output needs to become years since 2010, and our new input has to be deer population in DeKalb County. So we're going to take this equation and solve it, getting t by itself. They didn't define variables here, so in the end, we'll just double check that. So we'll start by dividing by 1,500. So we get P of t over 1,500 equals 1.032 to the power of t. Now the inverse of an exponential is a log. So currently we have a log base, or the base of the exponential is 1.032. So we do log base 1.032 of P of t over 1,500 equals log base 1.032 to the power of t. We know that on that side, that will simplify to be 1. So we're left with t equals log of 1.032 of P of t over 1,500. Again, their variables are going to be different because the variables weren't defined. But let's just see which situation matches what we just solved. This does not work, not work, not work. Oh, log base 1.032 of P over 1,500. So our solution is D. All right, now you know all the steps. So the steps from example 1, I scaffolded it for you. I took away the scaffold, so attempt the same thing to try and answer example number 2. So this is going to be the one that I check to see if you get correct. So pause the video and go ahead through that. All right. So go ahead, read through this blurb. All right, so basically this is saying that when we have a measure of earthquakes, they use what's called a Richter scale, which ends up using a logarithmic pattern to determine their measures. So if we look here, the Richter scale is a numerical scale that uses base 10 logarithmic functions to measure an earthquake's magnitude. The larger the number, the more intense the earthquake. As intensities increase multiplicatively by a factor of 10, the Richter scale increases additively by 1. So that shows a logarithmic pattern because our inputs are increasing multiplicatively, where our outputs are increasing additively. Consider 2 earthquakes that occurred in the year 2024. An earthquake in Noto of Japan has a magnitude of 7.5. And an earthquake near Bali, Indonesia, has a magnitude of 4.6. Approximately how many more times intense was the earthquake in Japan than the earthquake in Indonesia? So let's go ahead and take a look. So if we make a table to help ourselves, our X is our intensity. And our Y is our Richter scale. Measure. So we know that the measure of one of our earthquakes, so the earthquake in Bali was 4.6. And we said that the Richter scale increases additively by 1. So we know that we're going to be adding 1. So we get 5.6. We add 1 again. We get 6.6. So we're still not quite at the Richter scale magnitude of the earthquake in Japan yet. So we add 1. We get 7.6. Okay, so we can see that now 7.5 is going to fall between that 6.6 and that 7.6. We don't actually know the intensity of the earthquake in Bali, so we can say some unknown. Let's call that unknown P. However, we do know that the intensity of the earthquake that has a Richter scale measure of 5.6 is 10 times more powerful than that original earthquake. Again, at 6.6, we know that it's 10 times more powerful than the earthquake above, so it's 100 times more intense. Now, again, okay, to get to our 7.6, we know that this is 10 times more intense than the previous one. So 1,000 times more intense. But if we look, 7.6 is a little less than, or 7.5 is a little less than 7.6. So looking here, this is saying between 100 to 1,000 times more intense. So let's go ahead and look at our options. Well, clearly A and B are out of the question. It's not going to be 100 times more intense because 7.5 is closer to 7.6, meaning it will have to lean closer to 1,000. Since 800 is closer to 1,000, that would be our solution. All right, you are now going to use your steps that you just learned at example 4 to complete example 5, showing work, and example individual check, showing work. These will be questions that I check your understanding on when you turn it into the sum.